By the end of this lesson, you will be able to find the slope of a line given the graph or an equation. And that may seem like, hey, Mr. Williams, I don't know what slope is. How am I gonna be able to find the slope of a graph or an equation? And that's a great question. With that, we're going to get into our notes. We've just spent some time going over what a relation was, what a function was, all those different things that are related to finding slope and whatnot. All those things that we're going to use. We went over what our slope intercept was, what slope intercept form was. And that is all stuff that we're going to be using in the second half of our unit 3. We just finished 3A. Now we're getting into 3B. And by the end of this lesson, once again, you'll know how to find the slope of a line by looking at the graph or by looking at the equation. And you may be thinking, hey, Mr. Williams, I don't even know what slope is. How am I going to be able to do all that kind of stuff? And that, in fact, is a great question. That is a great question, and so great of a question. That's going to be our essential question for this set of notes. All right. So our essential question for this set of notes is going to be, I want to do this set. Let's do orange. How can I determine the rate of change, which is another word for slope, rate of change which is another word for slope. And we'll call it slope for the most of the time, but in case you see it as rate of change, you will know that slope and rate of change are the same thing. All right, so how can we find the rate of change of a function? There goes that part from unit 3A, of a function given, goodness, I can't spell, given either 2 points, an equation, graph, or a table. All right, that's our essential question. Great segue that you guys asked at the start. By the end of this lesson, we will know how to determine the rate of change, which is a slope, the rate of change of a function given either 2 points, an equation, a graph, or a table. We will know how to do that. All right. So let's get into it. Before, in that previous set of notes, that first set of that 3A notes, we went over what slope intercept was and what our standard form was. So just as a reminder, we have y, our slope intercept form is going to be y equals, and I'm going to try and use different colors, the same color for each one throughout this whole thing. Mx plus, and then we have a b. I'll do the b in red. Mx plus b. All right. That's our slope intercept form. And then we also have a standard form, which was ax plus by, should be a capital B, plus by. That y looked like an x. So ax plus by equals c. This is what we see many of our equations in this standard form, and we spent a good bit of time in the last unit taking things from standard form, the standard form here, from this going to that, to our slope intercept form. That's going to be really important for this unit, the second half of this unit 3, which is why we spent so much time on it on the first half. All right, so those are our 2 things that we need to bring back to our memory. All right, so 2 very important characteristics of linear relationships, and that just means lines. Okay, linear relationship is just a line, a straight line, can be seen in the slope intercept form, which is what we have up here. Slope, which is going to be our m, so I'll write that in purple. Slope, which is m, and our y-intercept, okay? Our y-intercept, okay? Our slope-intercept form has a slope that we can see and pick out really easily, and it has a y-intercept given the name slope-intercept. So once again, what is slope? We've talked about slope-intercept quite a bit, and we're getting more into it now. So let's go ahead and get a definition for slope. Slope describes how steep a line is. That's the definition right there. How slopey is your line? How steep is your line? Slopey isn't a word. Don't really say that. How steep is your line? What is your slope? It's going to be how steep your line is. And to further describe it, because a linear function has a constant rate of change, any 2 points can be used to determine slope. All right. And if you look back at that question, that initial question we had, we're already about to answer the first part. Okay. Once we get a little further in, we're going to answer that first part, which is finding slope given any 2 points. So slope describes how steep a line is. Keep that in your brain as we go forward. So there are a few different kinds of slope that we can see. We have a positive slope, and a positive slope will just be a straight line going up from the left to the right. It'll point up to the left. All right, let me go ahead and draw some arrows on this because it is a line. So the left side will be down. The left side will be down. That's a bad arrow. Scoot that over. And the right side will be up. I don't know why I'm drawing these out. I can just type them out, which may be better. Our right side will be up. Our negative slope, we will have the exact opposite. Our right side will be down and our left side will be up. Okay. Going from right to left, our negative slope is going to have left being up and right being down. All right. So those are the two probably most common slopes you will see, but we have two more that you need to be aware of as well. A positive slope like this, negative slope like that. A slope of 0. A slope of 0 is another kind of slope we have. When we have a slope of 0, we just have a straight line. That line doesn't move at all. All right. How steep is a straight line? It's not steep at all. It's flat. You can't have fun on a straight line. If you're trying to go skiing or something like that, it's going to be 0 fun because it's flat. So it's going to have 0 slope. And the last example we have is going to be an undefined slope. Okay, that's going to be a vertical line. How steep is a vertical line? This drawing is straight up and down. You can't really do anything with this thing. So instead of not having any fun, you just don't know how dangerous it'll be if you try and go skiing on a sheer cliff. All right, you don't want to do that. That's undefined. Our slope is going to be undefined here. So for our 0 slope, that's going to be, and I'm actually just going to type it out this time. 0 slope is going to be a vertical line. That's not vertical. It's going to be a horizontal line. And our undefined slope will be a vertical line. So we've got we've got four different kinds of slope here. We have a positive slope, which goes up from left to right. We have a negative slope, which goes down from left to right. We have a 0 slope, which is just a straight flat line. And then we have an undefined slope, which is a straight line up and down. All right. A straight line up and down. And so when we want to find the slope of a line, we have a formula for that. Our formula for slope is going to be our variable we're going to always use is going to be this m. Okay, remember that. It's always going to be m. And then we're going to have rise over run. All right, rise over run. I'm wishing I did slightly different colors for this stuff now, but it's cool. We'll make it work. Rise over, I'll do red for run, run. So our rise is going to be our change in our y values in the slope, and our run is going to be the change in our x values. Okay. Rise over run. You probably have heard that before. You probably do remember it. If you don't, you'll remember it after this. Rise over run, change in x over change in y. That's going to be when we have 2 points that we're looking at, we're going to have our second point, our second y value minus our first y value. That's going to be y sub 2 minus y sub 1. And that's just because the 2 is a subscript and the 1 is a subscript. That's what that sub means. So y2 minus y1, and then we'll have that over x2 minus x1. And these will actually end up being numbers. And you'll see that as we go on and do a couple of examples. Okay, so that's going to be our formula for finding slope. When we want to find slope from an equation, we're first going to make sure that that equation is in slope intercept form. All right, we want this thing to be in slope intercept form. And so that means we're always going to have it solved for y, which is what we spent a lot of time doing that last unit. We had everything solved for y. Slope is going to be that coefficient which is going to be the number in front of x. All right, that's what coefficient means. It just means the number next to a variable. So it's going to be that m. Do you remember up here where we said our slope is m? And then at the very top, we have y equals mx plus b. Our slope is going to, ooh, goodness, didn't mean to do that. Our slope is going to be the number in front of our x. So this m is going to be what our slope is. All right. So I'm going to do examples 1 and 3. You all do 2 and 4. And if you have any questions, ask me. Go back to the Zoom chat and ask me. So example 1 says y equals 3x minus 11. With our slope being our number in front of x, our number in front of x is, what color did I use for my slope? Purple. I'm going to try and keep the colors the same when I'm doing this. Purple is my m right here. This is the number in front of x. So I'll have m equals 3. That's going to be my slope for this equation, okay? When you go to do number 2, you have your number in front of x. When you go to do number 4, on this one, you're going to have to solve for y first before you get your slope, okay? Now let's look at number 3. Number 3 looks a little strange because we don't have an x in number 3. We just have y equals 25. What would that be? Certainly not an equation. I know that y equals 25 would just be a line. So this has no slope, okay? Number 3 has no slope. All right, and we'll go over some more examples like that in the future. If we wanted to write this out to be more specific, if that just confuses you doing it like that, let's actually throw in some of our values. We have y equals 25. So we have y equals 25, right? Since we don't have an x value, we can still throw one in there. We can throw it in there and have it look like something. But since in our original equation, we don't have an x value, what can we multiply that x by to make it go away? The only thing that I could think of where you multiply something and it goes away or becomes nothing is going to be times 0. So in this case, we have y equals 0x. We just put that in there to help you all see what it is. Y equals 0x plus 30 plus 25. And so when we do that, we see that our m is going to be 0. And so we're not going to have a slope, okay? If in the future, if you don't see an x or anything like that, you know your slope is going to be 0. You're going to have no slope, okay? So you all do 2 and 4. If you have questions about those, ask for help. Come back to the Zoom chat and ask for help, all right? So now let's get to what that first question was in our essential question. How can we determine the slope given 2 points? All right. So this says, first, we're going to label the points, label given points, x1, y1, x2, y2. Then we're going to substitute the coordinates into the slope formula. Do you see how this change in y over change in x is going to be equal to y2 minus y1 over x2 minus x1. And that looks exactly like what we had above for our definition of slope and our formula of slope. Our slope is equal to rise over run, change in x over change in y, y2 minus y1. So that's what we are going to do here. Let me, in this one I used yellow for y and red for x. So let's stick with that same color scheme. Yellow for y, we have y1 here, y2 here, and then we have x1 here and x2 here. So when we write this y2 minus y1 over x2 minus x1, I'm going to take this y2 here, which is my 8, minus, and actually I'm going to put this in parentheses so I can write it correctly in Kami. I have 8, my y2 minus my y1, which is 1. I'll close that parentheses. Divided by this x2, which is 7. Let me put this bottom one in parentheses as well. 7 minus my y1, and I have a negative minus a negative 3, okay? That looks kind of funky, but when we have minus and negative, what is that really? That becomes plus. Those two minus signs come together to make a plus sign. So really this is 7 plus 3. And what we get once we do that, we get 8 minus 1 on the top, which is going to give us a 7 over a 7 minus a negative 3, which becomes 7 plus 3. That gives us a 10, all right? So I'm just going to come back to the beginning up here. M equals, throw that in there. Our rise, our y1 minus y2 minus y1, x2 minus x1 equals 7 over 10. All right. I'm going to do C. You all do B and D. C says 7, 3 and negative 2, 3. When we do this one, I'm going to go and label my x's, x1 here. That x looks like a y. X1, X2, and now my y's are going to be Y1, Y2. And so now I'm going to set it up like I did that last one. Our formula for slope is change in y over change in x. We have m equals this 3, which is our y2, 3 minus our y1, which is also 3, right? All over, I need to move that up a little bit, all over our x2, which is negative 2, minus our x1, which is 7, all right? And when we do our numerator, our 3 minus 3, we get 0. And then we do our bottom, which is negative 2 minus 7, we end up with a negative 9. Whoa, Mr. Williams, what do we do when we get a 0 over something? Well, with 0 divided by any number, that's just going to be 0. Okay, so in this case, we have our slope being equal to 0. anytime you have 0 as your numerator or you're dividing something into 0, that's going to just be 0 because nothing can go into 0. And we have that one. So you all, once again, go ahead and do B and D. If you have any questions on it, let me know. Come back to the Zoom chat, let me know, ask them, and I'll go over it with you. Now let's look at finding slope from a graph. The first thing we're going to do when we want to find our slope from a graph is we're going to find a starting and a stopping point. You have to know where you're going and you have to know where you're coming from. You need a starting point and you need a stopping point. When you do that, once you have your starting point and your stopping point, you're first going to count the rise. The rise. So you're going to count from your starting point up to the same level that your stopping point is at. And then you're going to count the run. The run is going to be the distance from your starting point left and right to your stopping point. So first you're going to count up or down, and then you're going to count left or right. And you're always going to start, when you start counting your rise and your run, you're always gonna, I'm gonna put this one in red because this is an important one. Start on the left. Okay, I'm gonna start on the left. So example 1, let's look at example 1. It gives us our starting points. We have one here. In case you can't see it, let me draw it in. I'll draw this one in red. We have a starting point here and we have our stopping point here. When I go to find my slope from this graph, I'm going to count my rise. I started off by finding my starting point and my stopping point. My next step, step 2, is going to be to count the rise between the points. So from this point to this point, I'm going to start at the point and I'm going to go up 1. I'll just leave some dots so you can count with me. 2, 3, 4, 5, and 6. And I recommend when you're doing this, if you decide to print these notes out or something, you also put little dots so it makes the counting a good bit easier and you don't lose track. So we have our rise is 6, okay? And then we have our run. I used the wrong color. I should have used yellow. That's fine. I use yellow for the next one. When we do our run, we're going to count from this point over to our stopping point. 1, 2, 3. Okay. Our run is 3. So the slope for this line, our M equals our rise over our run. So 6 over 3, which is just going to reduce to 2. 6 divided by 3 is 2. Oops. Let me put that from under it, equals 2. All right. So now let's do example 2, and you all will do 3 and 4. And this time I will use the proper colors. I'm still going to draw my point to red because I like this. It's easy to see the red. So we have a starting point here. It gives us that. And then we have a stopping point here. These are the 2 points we're going to choose. When you all are choosing starting and stopping points, don't choose something in the middle of a box, okay? You want to choose something that's right on a point, that's at one of those intersections, that's at a crosshair to make the counting easy. This could be like, we want whole numbers when we're doing this. So don't pick a starting point or a stopping point that's not on one of the crosshairs, okay? So when we count our rise, we're going to count our rise first. We're going to start at our starting point on the left. Going to go up 1, 2, 3, and these orange ones are a little hard to see. 1, 2, 3. We got 3 there, and when we count our run, we have 1, 2, 3, 4, 5, 6, 7. All right, and we have 7 for our run. So when we go to write our slope, our M equals our rise over our run. Our rise in this case was 3, and our run was 7. So you all go ahead, do 3 and 4. If you have questions on that, come back to the Zoom chat. Let me know. I'll do my best to answer them. And finally, that last bit we're gonna cover is finding slope from a table. And this one actually isn't too bad. When we want to find the slope from a table, we're going to use the slope formula, like we've just been doing with our m is equal to change in y over change in x. And we're going to identify the difference between two rows. All right. So let's look at, and let me use a different color here. We're going to look going from this x to this x to find our run. So going from 0 to 1, that's obviously just going to be an increase of 1. So we got a +1 here. And if you want to check it, you can pick another one. From 1 to 2 is +1. From 2 to 3 is +1. And then to go from our, actually, let me keep the same colors. All right, that's red. To go from 0 to 1 is +1. And then for our y, to go from 5 to 8, the only way we can get there is to add 3. To add 3, okay? And then to check, let's go 8 to 11. That difference between those is just going to be 3. And so when we go to do our slope, our m is going to be equal to, oh, shoot, y'all. Let me go put this in the right color. This is supposed to be in that mustardy yellow color. From 5 to 3, it's going to be +3. 5 to 8 is +3. And so our m is going to be equal to 3 over 1. And then that's going to be equal to 3. So our slope for this one is going to be 3. Now let's look at another one. Example 2 looks a little funky because we see some decimals and it's like, I don't know what to do with decimals, but I promise you, stick with it. It's not going to be too bad. So let's look at our x values from -5 to -3. The change there, that's going to be, it looks like it's increasing by 2. But to check it, let's go to another value. If we go from 3 to 5, that's also going up by 2. Okay, so we know that that works for our run, for our x. Now, when we look at our y, we see our y going from 7.5 to 6.5. How do we get from 7.5 to 6.5? The only way I can think of right off is going to be to subtract 1. All right. And so let's check it. If we go to this last one, we go from 3.5 to 2.5. That's also going -1. And the reason I skipped it is just to check to see if my pattern holds true. So the slope for this one, my m is going to be equal to my rise over my run. My rise is my y direction. So I'm going to have -1, -1 over, and my run is 2. So -1 over 2. And that's going to be my slope, okay? If you have any questions on what that is, how that works, how to do any of it, go ahead and make sure you ask me. Come back to the Zoom chat and ask me. And once you finish through the notes, I want you all to use this summary box down here. Go ahead and type out your summary. And what I want you to do, we're going to do this little thing called muddiest point. Okay, with your muddiest point, what you're going to do is just type in where you got confused the most in this lesson. Okay, and that'll help me understand what to touch up when we do our warm-ups in the future, what to address when we go into breakout rooms and all that kind of stuff. Okay, so now that you see that on the summary, go ahead and throw in your muddiest point. Also, go ahead and try to summarize what we did for this lesson in just a few words. All right. And if, in case you've forgotten, our goal for this lesson, which I said quite a bit at the beginning, our goal for this lesson, by the end of it, you will know how to find the slope of a line given 2 points from a graph, from an equation, and from a table. So you've learned quite a bit this lesson. Once you finish, go ahead and get started on the practice. And if you have any questions, come back to the Zoom chat and let me know.